Okay, let me get started. Uh, Share my screen here. Okay. You see my screen there? Okay, great. Okay, all right, we're good. Yeah. So if you ever wanted to simplify your state logic in your React application, or maybe you're having some trouble managing the state of your applications, then you're in the right talk, because I'm gonna share with you many strategies using finite state machines, how you can improve your React applications, talking about the state management and how you can simplify them. I'm Percy. I'm a senior full stack engineer. I have 16 years of experience. I started using React in 2015. I specialize more in the JavaScript area and React, TypeScript, Node.js, uh, Golang, Python, and some other technologies. So first, we, we're gonna explain what is a finite state machine for those of you that don't know what that is, according to Wikipedia, the term refers to a model that can be in one or a finite number of states at a given time. And state machines can change from one state to another, given the inputs that we give it. In this case, I have an example, a turnstile here that we see in train stations or stadiums. It's a very simple example in real life, how you can see a state machine in action. You basically put a coin or a card onto it. And once you do that, it goes to the unlocked state. Maybe you try to put more coins or another card. It doesn't change from the unlocked state until you push through, and then it gets unlocked for the next person to go through it and do the same steps. So it's one of the simplest examples you will find in a finite state machines. The other one is an on and off switch. Obviously, you have on and off. It can't be on both on and off at the same time. So you have a very simple state machine right there as well. The question now is, why would you use a finite state machine? Specifically in developing a system, an application. So you have the ability to model the system. You can decompose it into different states, the system, that your system may have dynamic behaviors, and you decompose it into the states that it represents, it can be in. And you can also have a concise representation of the system in through the different states and transitions, moving from one state to the next. So you can have a very concise representation of that. And uh, additionally, you can debug the system easily because you can trace back what happened before. So you know how to debug any problems that happen, because it's very predictable, the way it works. It follows a path, and if you have a problem, then you trace back your steps and you can find what happened before that. And predictable and deterministic behavior. So you have it behaves consistently on the different conditions. It doesn't matter what input you give it. Maybe you can give it a wrong input, but it will behave the same. because it will always follow the flow that that state machine was designed for. So we're going to take a step back to define the different components of a state machine so we can have a better idea of how it works. First of all, we have state. Think of state at different conditions or modes that the system can be in. In this example here, I have a traffic light. It can be in green, yellow, red, as we all know. So it can't be on red and green at the same time. It can be yellow and green at the same time. So we have a very strict defined set of states that we can have on this example. So that is state. What are transitions? This is another part of the finite state machines and describes how the system moves from one state to another based on conditions that or triggers. So we have the transition in the traffic light example could be defined from the when it moves from green to yellow to red. So what happens? What triggers start that transition? And those are when it moves from one state to the next, that's when we have a transition because we're changing the state on our state machine. So as I explained, we have a flow. We're going to see an example later on of how it looks at a high level. Next, we have the events. The events are the triggers that cause the transition between states. So in this example, in the traffic light, we have maybe a timer that the traffic light has internally that when it goes to 0, it changes to the next light from green to yellow to red and continuously repeats that cycle. So events initiate the transition from one state and drive the behavior of the system. So in this simple example explain, how we can visualize events, Obviously, this is just for the traffic light. We can have on an application different ways of having these events. The next question you may be asking, but how do state machines help me in React? You guys have seen all of us in e-commerce site filling out those forms, shipping addresses, checkout forms. Well, that's basically in one of the ways that we can apply a state machine because we have many different components that should be interact with the user input and follow a flow. So we can, even on a single screen, we can create several state machines applying to the buttons, apply to the validation, or maybe to the coupon code that the button will be grayed out until we enter that coupon code in there. So we can manage all that in a state machine. Now we're going to take a look at one of the libraries that we can use. One of the most popular one to use Finite State Machine in React, which is Xstate. Xstate is an incredible library that allows us to create state machines by using a JSON object. It allows us to create a hierarchy of nested state, execute actions when transitioning between states. So it's like we execute a bit of code when we move to one state to another. And we can also implement guards or conditions that must be satisfied before transitioning. So we can have even validating before making a transition to the next state. So which is very handy. And also as a added bonus, we have a context, which we can pass variables and share between states so we can do any kind of logic that we need to do in there. So now I'm gonna share an example how it looks. I don't know if you guys can read it well, maybe. Can we turn off the lights? Or maybe, yeah, or maybe there, yeah. So I have an example of not using any state machines, pure React code of a simple component here. So I have here three states: firing, fire, faulted, and the requirements are when the user clicks the button, it should only say firing after clicking, but until the function fire function returns. After we fire successfully, it should show boom only after the fire function is finished without errors. If there's an error in executing, then only oopsie should be shown. So very simple requirements. This is just like a button. We have a click handler here that when we click it, it runs this piece of code here. And we have the three states represented here. And if we have an error, then we set fire to false. We don't have an error. We set fire to false, set firing to true. And you can see the same requirements satisfied here. If we have an exception, then we set it to false and we set the faulted to true. And if we get to this branch, then these two lines won't run, okay? And here, look at the code. Very simple. It looks very simple. You know, if we have a firing, it will show firing on the label. If it's fire, boom, it will show the word boom. And faulted, it will show oopsie, right? Very simple. You would say, well, this is simple. How can I simplify this? But the truth is, when we're working on a team and we get another requirement added to this, we can easily add um, create another condition, maybe missed uh, some another of the state that we had, and we can create a bug easily in there. So I'm going to show you now the after applying a state machine to this code. So now in this code, we have the same requirements. And look how simple the handle click function is now. It's more readable. We have, we're importing the state machine. I'm gonna show what that state machine code looks like, but just looking at as an overview how we can apply a state machine. And we have the send. That's how we send the events to change the state. So we have, we're changing to the fire state here and then waiting for that method to execute. Maybe we're pulling data from a server. We're waiting for it. And if we get an error, then we set the exception here. Otherwise, we set the success, and look how we handle everything cleanly in the button with the labels. So this code is much more simpler to maintain, easier to read and maintain, obviously, and it's more difficult to introduce bugs to this code. So this is like a quick overview of that, how it looks like at the end. Yeah. So this is the state machine diagram of what we created here. We have an initial state. When we fire, it goes to the firing state, and when we succeeded, it goes to the fired, and we can repeat that again, firing, and if it fails, it goes to the faulted state. So this is a very simple example, so you guys can see how this type of finite state machine looks like. So as an overview, here's how we create a state machine with X state in React. We declare that JSON object, which is the definition of the state machine that we're gonna see briefly. We initialize our state machine using useMachine. That's the React hook we use to import that state machine after we initialize it. And we implement any logic with current value, current dot value or current dot matches. There are more ways, but this is the simplest way you guys can get started with. And trigger transitions with the send method passing the name of the event. And obviously it will follow the same flow that we give to our state machine on our JSON. I'm going to show that now. This is how it looks like our JSON of the state machine. This is the example of the traffic signal. So we have the initial state set to red. We have the different states, red, green, and yellow, and we have our events. We have our event called timer, which we can trigger. And from this event, from red, I'm calling it to go to green. And from green, it goes to yellow, and yellow goes to red. So that's a very simple example of how the state machine JSON looks like, how we can define it with XState. And this is the implementation of it. Let's say I'm importing this from another file. I get my hooks here. I can evaluate my current state here, and maybe I didn't include any CSS, by the way, but you can imagine that active is just making it visible, the color of the traffic light. So every time it evaluates to any of these, it will activate the color of it. And I'm sending here on a button the timer event. I'm triggering the timer event on click, and that changes the signal light to different states. So it will follow the same flow that I designed previously. So it looks really manageable and easy to read. So now I want to show a more complex example, because you guys may be thinking, well, maybe I can apply in a few things, but maybe in others, I wouldn't know how to use it. I'm gonna share some code for another more complex example. Also known to the whites as Sam Jones. Other was Okulka. He was known as the prophet because Mikasuki thought that he was in direct communication with the Great Spirit. And they decided that they were going to have to make a statement to General Maker. So I have, this is like a shopping cart. You see a product here. There was a we select next. Territory that Maker had promised these products. Select the shipping methods. Let's say I just click next. I get an error. Must select a shipping method, of course. And of course, I click next. And I complete this form. And on the night of July 22nd of 1839, for whatever reason, whether he was lax or because the instinct, treaty with them, did not bother to post any sentries. And the following morning in the pre-dawn hours, three warrior chiefs. One was a gentleman by the name of Halader Mika, or the Alligator King, the Alligator Chief. Another was Chiquika. So fair enough. That's the code. That's what the code does with this form. And there are many ways you can build this in React, of course, but I'm going to show the way that I use just using finite state machines. Okay, so I'm going to share my code editor here. The creator by the name of Dahlem, his two clerks, Morgan and Smith, the riverboat pilot, a guy by the name of Major McCarty, all of them were killed. But Harney and 8 of his dragoons managed to escape in their nightshirt and underwear. And they escaped by basically swimming across the Palouse, catching to the southern shore. As a side note, Harney did get a measure of revenge. In December of the following year,
200 men, and they captured and hanged Chiquita and 5 of his warriors. And with them, that was the last vestiges of the Calusa nation. Arson Calusa that still live in the basically in the genealogy of Cuba, but that was the last of the Calusa that was remaining.
Okay, so here's the code editor. Um, so here's the everything is happening here on the app.tsx here. We have this main component. This is the main part that everything's happening, where even as I move from one screen to the next, everything is is within this component that I have here. It's because I'm using the context, which I'm going to show how that works. And I'm importing the state machine. I'm going to show the state machine code here. So this is the state machine, Finite State Machine. And I have the context, setting it to an initial screen. So here I have a code that is mapping to the different screens that I have: the shop screen, the shipping, the final checkout, and the thank you. If I go here to the
I had no intention of getting into meteorology in any depth or
so I have the different screens here imported.
And there's things that came about that were kind of surprising.
And I'm initializing my states with all the different screens. I have the shop screen, shipping,
Well, like Dirty Harry once said,
and payment, and thank you. These are the main states as screens. And within each of these states, I have nested state. I can even have nested states inside of it. So inside I have a loading state and loaded. A loading state invokes a function that it will get me the order items. And when done, it will execute this action to set data with the items that I got from it. And once that happens, it will target the loaded, and the loaded is here. And it will exit executing this function set loading, which is just sets the loading state to be active. Um, after we finish, after we click next, it goes to the shipping state, which is here. And we have almost the same kind of logic inside the shipping state. We have nested states here, loading and loaded. It will get the shipping methods from the network, and it will trigger the loaded once it's done, which is here. And the difference is it has two actions. Instead of one, it has two actions. That's why I have an array here of two actions. So it will execute each one in order. So once I click next, it will execute these two actions. It will, this is a conditional. So if shipping was selected, then it will let me to change the view. Otherwise, it will display the error that you guys saw previously, must select a shipping method. So everything, as you guys can see, everything is self-contained in that state machine. So I can easily change the order of the screens, add more validations to it, and it will continue to work. So after that, if I selected a shipping method, it will change the view to the payment, and it will move here. And from the payment, it will change to the thank you page here.
all of these little islands.
So these are the different, how I import the different actions.
There could be a barrier to the search, but what
So I have
angle
the different actions that I can define in a separate file. I'm importing them at the top of the file here.
they just serve
So I can define those anywhere and import it into the state machine, and also the guards,
that
which was checked here,
foot of search
was shipping selected.
way back.
This is here.
Those structures I showed you before.
So it will validate that I have a shipping method selected that is not null. So as you guys can see, this is all self-contained inside the state machine. So I can create almost anything, any logic I want in this code, and
Looking at that
it will be much easier to implement.
process. And according
So I have here the code. I import that component.
there was 14-foot of inundation measurement.
I said import the props for this component. I have in the context I have the props. I'm going to show you guys where these are. So here's the context. Here's the current view and all the different variables that I'm using in this state machine.
You want to know where you're at, how much.
And the way I update them is on the different actions. I'm going to show just one of them.
That calculation, you got to know three things.
The change view.
High tide, low tide, or somewhere. What's the surge that they're telling you? How
So
much
here,
that are going to be on top of that? And then
I'm changing the view. I have this map to view, and I'm using the payload variable to map to return that specific screen that I want to go to. Or if I don't have that payload, we can return an error, throw an error.
So I thought this slide was kind of interesting.
So it's a more complex example. I know it's a lot to digest at once, but you guys can see with this example how powerful, this state machines can be when you're managing your React applications, and you can practically model the entire React application inside the Finite State Machine. So everything can be managed through that JSON object.
Message tonight is Ian was not an isolated event. We now know there was 5, but almost like 8. But
And finally, I have this the send, which is the click that I have, the click next button that sends the next event here. And that's how I move from one screen to the next.
A guy by the name of Jacob Summerlin.
I know there's a lot to look at this on this code, but it's to give you like a big higher overview of how you can apply into very complex applications, and you can self-contain all that logic inside your Finite State Machine.
The reason was Cuba was paying $15 to $20.
So I'm gonna go back.
Whereas domestic market, they paid only $4 to $8. So it was a very lucrative enterprise to take steers to Cuba. And they started that in like 1856, and in the year preceding the Civil War, Summerlin had a very active cattle export trade going on with Cuba through McKay. During the Civil War, McKay and Summerlin began blockade running.
Okay, we're back here.
McKay's ships were northern sympathizers.
So that was a more complex demo, like I said. You guys can start implementing a very simple state machine, like the traffic signal, and then start implementing and testing the features that XState gives you out of the box. And also, they have a very good documentation that you can check out in their site, which explain everything very cleanly. Now you may be asking this question.
And facilities on Ponderosa.
But you can take it one step at a time. You don't have to rush implementing it to any application you're currently working on. You can try it on a simple example and say, okay, well, let me see how I can apply it to this piece of my UI, how I can simplify the code, how my team reacts with that implementing the state machine, and go from there, because the possibilities are endless with XState.
That the International Oceanic Telegraph Company, the IOTC,
Okay, questions.
Western Union, was going to come in,
Yes.
appropriate those facilities under an act of Congress that said they could. And so when the IOTC arrived, they didn't boot out some of them. Rather being cagey, being a good business company, what they decided is they would have their man, George Schultz, collect a pork chop.
Yeah, the finite state machine is like you're defining a clear path, how your system is going to work, moving from one point to the next. So you have a predictable behavior on your system. So when you have a predictable behavior, you know that two conditions cannot happen at the same time. And that way you can know a specific flow that you should follow on your application. So state machines help you model that.
There is a
Okay, no problem. Any other questions?
about build facilities at Hunter Ross. Some
Varela,
maintain that it was
your
Summer
question?
that built them in the 1850s. Others maintain it was the IOTC that built them. The better view, though, is that it was the Union Soldier in 1864 that built them. And as evidence of that, this is a rare picture of the inside of what's called the barracks. And you can see, you have a long hallway.
You can use plain JavaScript or TypeScript. It's your preference what you want to use. It's very lightweight, doesn't add too much. It's like 40, 50K, so it's not much.
Kind of capacity. Or the big mess tent, the big mess hall that was down at the end of the hall. Regardless of who built it.
Yeah, I know there are others, but this is the most robust there is, in my opinion.
Summerlin's bringing in these
Yes.
of cows, and they're loading them on the case ships at the end of the dock, and they're taking them. Well, the cowboys arrived with herd. They needed someplace to sleep. What they were doing initially is they were spreading out their bedrolls underneath this facility. The barracks were built on 14-foot pilings across. And
usually how I approach it is I break down the features that I'm working with, and within that feature, I can break different pieces that I know that the user will interact with those pieces, and then, I define the different states, and that's how I would break out per feature. It's not like you have to model your entire application like I did. This is just an example, but you can take that feature, divide it into the different ways the user can interact with that feature, and just determine, okay, this is a specific state that the user will see the screen or the buttons or the UI, and start breaking it down that way. So you don't have, and also another way is when you have too many if conditions on your code, on let's say a button, or you're showing a different component based on a certain condition, that's a good opportunity for you to use a state machine.
Lakeland, Ponderosa, there was going to be a certain amount of weight loss.
Yes.
So if you could cache your herd closer to the shipping point, cattle drive would be far less, and therefore there would be much less weight loss. So there was a business exigency there.
Yeah, XState offers a way that you can copy paste that JSON object, and you can paste it on their website, and it generates the state machine, so you can test it and you can visualize it there. I didn't show that demo here, but it's available on the site. You can test any of your state machines and you can visualize it, which is a very handy tool to use.
Before the new 5 strikes Ponderosa, George Schultz got married to a buried it in her grandma's house in Jersey. We had, although I
Yes, of course.
found any
Let
kind
me
of
show.
what
I have it open here, I think.
parents in Ponderosa would have been interested to find out. But she arrives 5 weeks before
Yeah.
and 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 the trajectory of this 5 was a little bit different than the one that struck in 1841, but the result was the same. It covered Ponderosa with 14 feet of inundation. The reason we know that is because the bottom floor of the barracks was 14 feet above ground. It was sitting on pilings that would cause breaks. And Schultz relates to the fact that the water was lapping the floor and coming in.
Okay, that's the state machine there.
Barracks. 14 feet of inundation, 1.5. And again, if you look at this, Max.
So it's a bit. Let me zoom in a bit. So everything is here. You see the checkout flow, the shop goes to the shipping, and then it moves to the payment, and you can see the nested state inside of each, the ones that have nested state.
There was a guy by the name of William Allen,
so that
his son George. They were doing, raising soybeans out there, Casper beans, rather. And the saltwater inundation.
No, it doesn't follow any specific API of X state. It's just the naming that I chose to use for those states. It can be anything. It can be ABC, whatever you want to put in there. And those are the names of the functions that I wanted to use. These are states too. So everything is here. You can copy and paste your state machine and you can visualize it immediately from here, which is a great tool to use to test it and to visualize it before you implement it.
That were never asked and never answered.
Any other questions?
Conflicting source material that suggests that prior to 5, Henry built his own facilities further up the point in the barracks.
Okay. No problem.
Hurricane 5 struck in 1873. The